Hi everyone, my name is Milad and today I'll be doing a system design practice exercise. I'm doing this to improve my skill set and hopefully in the process you learn something as well. Please be sure to always double check anything you hear and see in my videos. There are people far more capable than I am out there, and I would double check anything you see or hear. If you do enjoy the video, please take a moment to like, comment, and subscribe. With that, let's dive right into it. Today I'll be designing a video streaming service. What I want to accomplish here is support efficient streaming of high quality video content, allow content upload, handle a high number of simultaneous user connections, maintain low latency in video delivery across various geographical locations, track user watch history, and generate recommendations, track user engagement, and system performance metrics. Okay, looks like we got quite an ask here. So why don't we start with the database schema. I'm going to leave out basic tables like user tables and other information that isn't relevant to what we're trying to achieve here and is taken for granted. So we'll start with user movie, and this will identify a movie a user has watched. We'll have user movie ID, user ID, movie ID. We will have, let's do date stamp, when they started this, date completed, and then what else do we want here? Movie, and let's go generate. We also want to give movie rating, user movie rating, user movie, actually we can just do user ID and use movie ID as the primary key, combining them two, and rating, date stamp. So here is, this will allow us to rate a movie. We can either allow a user to rate a movie once or multiple times. That's really a business decision. We don't want it in the user movie table because remember, a user can watch a movie multiple times. And movie progress, so we want to track when the user where the user start and stops, so that in the event we want to allow them to resume. So last timestamp. This will be the last movie timestamp. This will indicate where they stop. Now this will allow us to see how many times it took them to finish how many times they watched the video and stopped. Right, we have movie. Let's see, movie, yep, we want a movie table, and here we will have movie ID, name, description. Now movie can have many genres, so we'll leave that out of there. And we'll have date stamp, status ID. This will give us different statuses, whether we want to have like different statuses, whether a movie can be active, inactive, paused, reported or something like that. Other things we can have, there's many other things we can have here, like movie genre table, movie actors table, and many other things, but for the sake of making progress here and then coming back and enhancing it, I think this is a good starting point. This will satisfy everything we need so far in terms of allowing us, okay, so there's one other thing, movie files. This will give us movie ID, and we will have resolution and bitrate. What we want to do is whenever we upload a movie, we definitely want to generate many different resolution and bit rates, and depending on our user's resolution and network connection, we will decide what to use. And another thing we want here is we want part, or you can name this order. You can call this section, and this basically you can take a single movie and you break it down into different sections, starting from 1 to however number of sections you want. And we can also even have additional data. There's many more metadata you can have in here, and like duration and other information. There could be also movie caption, movie languages. So let's stop there and move on to the next thing. Alright, so this will be one of the most important things, is maintain low latency in video delivery across various geographical locations. Alright, so whenever you want low latency, you definitely want multiple data centers, but because videos are mostly static, well, they're static content, so that means we'll be utilizing CDNs, and CDNs stand for Content Delivery Networks, and basically they are servers set up across the world that allow you to deliver content without the user needing to go to your servers, and they're designed to be super efficient and low latency. So we will use CDNs to store all of our video files in them, and then because they're distributed across the globe, some CDNs will have specific, you can target CDNs with specific content based on language, trend, and other metadata and metrics that you want to make a decision on. So let's talk about connecting to our actual service. So we will definitely want, without doubt, a global load balancer. This will be the first entry point for any user connecting to our system. And then we are going to hit our regional load balancer. And our regional load balancer will once again redirect to our gateway. Now, if you want to add an additional layer of optimization, you can even go down to another layer of load balancers that are more local to a specific area that's really high population and high volume. So with that said, let's take a pause here and take a look at the type of APIs we'll be utilizing here. So we definitely, once again, I'm leaving out the very basic and APIs like login and all those things, and just focusing on the requirement that's here. So we would have a get video list. So here, this would be a list that the user would see as soon as they hit the system. So they log in, they come up to the screen, and now they're seeing a list of videos. Now we want to do get video detail. Now this will be if a user clicks on a video, and they're going to view the description, maybe images and other details about the video. So then we're going to do get video file, and when they click play, the system will then send them the location of a file, and the client will use that. We can call it URL. The client will then use that to get the video file and start streaming the video. Other things we might want to do here, that. So here our data would simply be, there'll be an access token, and through the access token the system will be able to determine who the user is. Here we would have a video ID, and here again we would have video ID. Now what you could argue is that video detail can return the video URL. The reason why I added an additional API is we want to secure the content on our CDN so that it's not a static URL. We want to basically create a secure or assigned URL so that it expires and only a single client or only a few clients have access to it, and we generate it on demand rather than having it sitting statically in our data set. Okay, so let's see. That satisfies all that. The other thing we want to do is, when we think about user engagement and system performance, I always find this to be simply a data store. User activity. So every time our users interact with our system, we will capture all their activity, whether it's logging in, scrolling once, scrolling twice, pausing, clicking on something, rating something. All these things will be sent to a data store and allow us to track and analyze user behavior. And the way that would work is we would have a messaging queue, something like a Kafka topic, that as soon as the API gets some sort of request from the client, regardless of what it is, it will write to this user activity topic, and then we will have activity service that will subscribe to these, consume them, and write them to our data store. Now the good thing about capitalizing on a message broker is it's super fast. You send a request and can continue without waiting for a response. It's asynchronous. Alright, so that takes care of track user activity, and then we want to also track system performance. For something like that, we might want to utilize something like, there are many ways you can do this, and Grafana is one way to track your system performance. It really depends on what you want, and basically what happens is the system is designed to track the performance of, you know, your CPU usage, memory usage, and all those other things that you can monitor and respond to if you need to respond to, like, say, a severe issue, SEV 1 or SEV 2, depending on the type of issues that you're running and tracking. Okay, so let's go on to getting a video list. So when the user connects to the service, once again, we hit our global load balancer. Our global load balancer will determine what the most appropriate regional load balancer is for you, send you to a regional load balancer. With a regional load balancer, the way you direct those requests really depend on the type of algorithm you want to use. There are many out there: round robin, least volume, least latency. It all depends on what makes most sense to you and moving in that direction. Once you hit the gateway, what we're going to do is we are going to hit a video service. Once again, I am leaving out basic things like OAuth or access verification, user verification. Those are just granted in any online system, so I'm just leaving those out. But if you look up any system design video, they'll cover it. It's pretty basic. You decrypt the access token, make sure that it's fine, and check that the user is still active, and then move on with the request. So the video service will get the request to get the user's list of videos. We will have in our system obviously our database, and this will be a new SQL database. New SQL is exactly like MySQL SQL database, except it was developed more recently, designed to be optimized for cloud computing, allowing it to be scalable and have the benefits that many of the NoSQL databases like MongoDB have, allowing it to scale horizontally. Conventionally, SQL databases were mainly scaled vertically, and to scale them horizontally allowed for a lot more complexity than doing that with NoSQL databases. We're reusing a relational database because there are many complex relationships here, and based on that we want to be able to maintain the integrity of that and query them when necessary. Over here in our data store, because we can have many different types of metadata we can track it, this would be a good place to utilize MongoDB. MongoDB is unstructured, and you can adjust and adapt what you're tracking as the system becomes more mature and grows. So this is where we will keep all of our user data, and this is where we will keep all of our user activity. We will then, to make sure we have maintained low latency, we want to upload all the user information that would be potentially utilized by the video service into our Redis service. Redis service is a cache server. It maintains information in memory, which has really fast access time. This will contain information about the user video details and user. Let's be consistent here. JSON I'm using. Alright, so let's just do video details, user video list. Now you can break this up into multiple Redis servers. That anytime you add a service or split it, that adds a level of complexity, overhead, and maintenance, additional monitoring. For the sake of simplicity, we'll simply have all this information in a single Redis server. So then what we do is we send the user ID, get the video list for that user back, and then send that information back to the user, back to the client, and the client end will translate that and display the information. Now, same thing here. We are sending a video ID, and this will hit the global load balancer, regional load balancer, our API gateway, our video service. It'll send over a video ID, and that will return for us the video detail. Now it's worth mentioning here, what I'm basically doing is just focusing on movies. We could definitely expand this to shows, which would modify our database schema, but for the sake of just moving forward, I'm just going to focus on movies right now. And then finally, what we want is to get a URL. And what we want to do here is so what will happen here is we will get the video detail. The request will come to the global load balancer, go through the pipeline, hit the video service. The video service will get the video details, which contains the URL, and then it will use our generate signed URL service that will return a signed URL, which will secure access, which will grant the client access to the CDN that is available, to the content that is available on the CDN. And it will return that URL to the user. So now, when the client on the user end clicks play, that request will now go to the CDN and get the first section. Now, what this will do is, depending on how you want to structure this, you can append to this URL section 1, 2, 3, 4, and it'll continue until it, let's say, hits 5 and the video doesn't exist and gets an error message back knowing that it's reached the end of that video. Okay, so that will take care of us watching a video. Next thing we want to do is allow content upload here. Okay, so for this, when a user comes along and has access to upload videos, they hit our API, and as soon as they hit our API, we want to store the video that they are uploading. And we can store it in something, a data store like S3 bucket that Amazon provides. It's a blob storage. Which stands for binary large object storage, and video files are an ideal place to store your video files. So as soon as you're uploading it, it goes directly to the S3 bucket here, and then what we want to do is, as the system is uploading it, it will eventually, once it's finished uploading, it will then write to another message broker, another Kafka topic, new videos. And what we'll have here is video processing service. Now the video processing service will be subscribed to the new video topic, and from there what we want to do is now process the information. So along with the raw data file, if we look at what we're uploading here, when we upload, we got post video, and we will have our access, token. We will have title, description, etc. And then obviously the file. So the way that works is we hit the API, that starts loading, saving the information to the blob storage. Once that's complete, it will write that to the topic along with the new location of the file, and then our video processing service will now need to process this, and what we'll do is we'll have a movie DB new sequel. Once again, here you could have them in the same database, but when we talk about scalability, we definitely want to optimize as much as possible, especially if low latency is really important for us. I mean, this area, in this specific example, isn't, but having them separated allows for some additional fault tolerance. If one system goes down, the other is still operational. So it will write that information into our DB, and then it will write this to other services. So now what we want to do is we want to take that video, it's a single file, we want to break it up, and then we want to create different resolutions from those from that single file. And what we can do is have different formats here. There are two main formats that are used. HLS stands for HTTP live streaming. That is one format used for video streaming. And then the other one is Dash. And these are the most common formats used for streaming video. So what will happen is we will now have these also subscribe to these topics. And they will take them and generate different bit rates and store them into another long-term S3 blob storage. Now they take a single video, they will generate many different bit rates and resolutions and save them into our long-term storage here. So now what we want to do is track when these videos are done processing. And basically every time one of these finishes processing a video, it will write to this topic, and then over here what we will have is we will have the video processing service listening to this video processing complete topic, and once it's complete, it'll update this it will update the movie DB to ensure that it knows that it's finished and ready to be processed and made available. So next, what we want to do is we want to do video, we can call this video handler let's just call it ready video. Let's just say video ready service. And what this will do is it will subscribe to this topic, and as soon as it knows that a video is finished processing, it will grab the information. So when we're uploading this information here, we are also storing the URL and everything. It will then hydrate our Redis server with the information, and then also upload that content to our CDN. Okay, so that is, let me think about this for a moment. It seems like pretty much what we want to accomplish here. So now what we want to do here is talk about scalability. And when we talk about scalability, whenever it comes to database optimization, the biggest way to optimize and make them scalable is making sure you shard your database. Sharding is the process of, instead of taking, let's say, your user information and saving it on a single database server, what you do is you find a key that you utilize to split the data into chunks so that you distribute that information across multiple servers and know exactly where to go whenever you need to grab that information or update that information. The next thing is having the service, having database as a service allows us to scale these things horizontally based on configurations that we deem that our business would find most appropriate. Database as a service. The rest of our system will be built on an elastic infrastructure. So all of these services you see would be built on top of Kubernetes. And what we do is, as the load goes up, and based on how we're on our Kubernetes has its own monitoring service. As the service is being utilized and CPU or memory usage is hitting a specific threshold, it'll generate additional pods, and these pods will contain the services that are processing the requests that the users are sending to the system. What you would do is have many K8 pods set up. So many K8 nodes set up, and each one of them will manage its own pods. And then on top of that, what you want to do is also scale those clusters, have them auto scale. That means that imagine each K8 node being a single server with a limited capacity, and at some point you're hitting the maximum capacity of that specific node, and you need to scale up and down as necessary. And that's where cluster autoscaler comes in, which is a scaler on top of a scaler. The other thing we want to do is, for a Redis server, we definitely want to make sure that is a part of a Redis cluster, and that's basically allows us to hit a single point, but multiple points depending on how you configure your system, and utilize a cluster of Redis servers. This allows us to have redundancy, failover, and fault tolerance if you take all of these things into account. Alright, and that is all I can think about right now. If you see anything I've missed or any mistakes I made, please, I would really appreciate if you posted a comment and let me know. I'm looking to improve. I hope you found this video useful. If you liked it, please, once again, take a moment to like, subscribe, and comment on the video. Thank you so much, everybody. Have a wonderful day.